Let's look based on the types of properties that we have in terms of the models that we can use in order to predict the properties. Okay, so first of all, we look at the models for primary properties. Okay, so of course, since we know that primary properties are properties which are which are depending on the structure of the molecule, so it would be good if we can use property models that employ structural variable. Okay, so we have a type of model which is called group contribution approach. Okay, the abbreviation is GC. So GC approach based on the MG method. So MG is Marrero and Ghani. So Professor Ghani is one of the author of this book, right? So this model is simple and also accurate. Okay, so basically, I have given you the task to read the paper, right? So I hope you have read that paper on Marrero-Ghani method. So I'm sure you also would notice that for that model, it has an extensive group parameter table, which can be used to predict a broad array of properties, and can include a vast variety of molecules. Okay, so the property prediction model has this form. So basically, at the left side is f function of theta. So theta is a function. Sorry, theta is basically a primary properties. So this is a function of primary properties. Right side. So we have the first term is the summation of the so the first term is basically for the first order group. So Ci is with respect to the contribution of first order group of type I that has Ni occurrences. So I can be CH3, OH, CH2O, right? So contribution, what are contributions? So contribution are actually a parameter value which are obtained through parameter regression of the model with a known experimental data. Okay, but that one we won't go into detail in terms of how the models are being developed. But it's good for you to know is that that the contribution are obtained in that way from through regression of the model with experimental data. And of course, you can read the details in the paper that I have shared. Okay, so and then D is the contribution of the second order group of type J that have MJ occurrences. So Ni and Mi are the occurrences of the group which are appearing in the molecule, in the whole molecule. So if let's say in that molecule you have like 3 CH3, then Ni is 3, right? So basically like the group vector that you have learned before, right? So 3 CH3, so 3 is actually the number of occurrences. Okay, and Ek is the contribution of a third order group of type K that has OK occurrences. So all this in the molecular structure of pure compounds. Okay, so based on what we have learned before in the molecular representation, right? So in terms of the group vector, so basically those groups representation is based on first order group. So in this Marrero and Ghani model, they have a higher order group, which is called the second order group and third order group, which can be used to provide more information in terms of the structure of the molecules. And normally second order and third order groups are used for polyfunctional molecules which have a larger molecular weight. So if we have just a low molecular weight of compounds with mono function, then of course we can just use first order. It's not necessary to use second order and third order, but it would be useful in terms of increasing the accuracy of the prediction, especially when you have components like this which are a bit complex with high molecular weight and have many functions, right? Okay, so this is the model. So basically for the contribution C, D, and E, so we can get it from the parameter table, which I will provide to you, or you can also get it from the journal. Okay. So, and for N, M, and O, and this is of course based on the molecules, right? So from the molecule itself, you can identify how many occurrences that each group have, right? Okay, so we know that this is Murray and Ghani. So the right side is clear in terms of how to get it. What about the left side? So the left side of this equation is based on the type of property that we are interested in. So these are a partial list of primary properties for MG model. And this is only a partial list. There are many more primary properties that the MG model can be used to predict. Okay, so how to use it? How to use this? Okay, this is the properties. So this is the unit, and this is the function. The left hand side of this equation. So for example, if you need to predict normal boiling point, then what you need to do is that this equation, the left side of this equation, you just need to change it to this term, right? So basically, if you want to predict, let me see if I can write something there. Okay, so if you need to predict normal boiling point, so basically this left side you just need to change it to the term which you see in the table. Okay, right. So that's how you do it. So TB is the normal boiling point that you want to predict, while TBO is a constant. So the constant value you can get it from this column. Okay, so the only unknown here should be TB. And so for the parameters, you can get it from the journal. So you just sum all the terms at the right side, and then you just find the value for TB. Then you will get the answer. It's quite easy. It's quite straightforward. Okay, and of course you can if you need to predict other type of properties, you will just use the needed function. Okay, if you look at this equation for heat of fusion, for example, it's quite easy because it's just like this. The term basically, in order to calculate delta H FUS, then you just add the right side with this constant, and you'll get the value right away. Okay, it's quite easy. Okay, this is how you apply the model. This is the in order to predict primary properties. Okay, so the first one is, of course, first of all, you identify the functional groups. Normally, we would just use the first order, but if necessary, then of course you can add the second order and also the third order groups. Okay, so based on, of course, first of all, before identifying the functional group, of course, you need to have the structure first. Okay, you need to find the structure of the molecule based on the structure of the molecule, and based on the list of groups which are available in the for the Marrero-Ghani model, then you identify or you break it down into the types of functional groups available. Okay, so you can first break it down in terms of the first order group, and if you think that you need to add more information to the structure, then of course you can add the second order group. So in order to know how to when on or how to use the second and third order groups, I would recommend that you read the Marrero-Ghani paper, which is for the year 2001. Okay, we have two papers, right? 2001 and 2012. So basically, the paper in 2012 is an improvement of the parameters, right? But you know, to understand the usage of the types of group, right? For second order, third order, better you can if you can read the paper for 2001. Okay, right? Okay, and of course determine how many groups of each type are needed to represent the molecule. And then after you have represent the molecules using the molecular vector for first order, or maybe second and third order as well. So then you can retrieve the parameters from the model parameter tables for the properties of the interest, right? So then we can calculate the right side of the Marrero-Ghani equation, right? And whereby you can sum all the contribution. and then use the corresponding property model, which is on the left side of the model. Okay, so let's look at an example here. Okay, whereby we need to estimate normal boiling point of butanoic acid diisopropyl ester. So here is given its SMILE. Okay, so what is SMILES? So for each chemical, they have their own SMILES. So what is SMILES? SMILES is actually like our identification card, or maybe like our fingerprint. So each people have different fingerprints, right? For example, so here when talking about SMILES, so each compound also have different SMILES. So this is just one way of how we can represent molecules lah. Okay, and the one given here is the CAS number, right? CAS chemical registry number. So basically these two information can provide us ways of how we can find information related to this compound. Especially here what we would like to have is structure, because from the SMILE itself we cannot clearly see the structure, right? Because there are no hydrogen atoms, and also it can be confusing if you don't really know how to read these SMILES. Okay, so so we need to estimate the normal boiling point using MG method and the related group contribution parameters. Okay, so solution. Okay, identify functional groups. Okay, so we have these molecules. Okay, so what you can identify from this molecule. So from this molecule we have, let me see, we have CH3 here, right? We have another CH3, two CH3, right? And then we have we can have a CH2COO here, right? And then we can have another CH2COO here. So meaning that we can have two CH2COO, two CH3, and we can have one CH2, two CH2, three CH2, and four CH2. Okay, so that would be our first order lah. 2 CH2COO, 2 CH3, and 4 CH2. Okay, betul tak? It's the same, right? So here we have 2 CH3, 4 CH2, 2 CH2COO, and this is for this first order type of group, and the contributions here we can get it from the paper. Okay, and in this example, so this molecule is also described using a second order group, which is COO, CH2, CH2COO. Just one of inilah. Okay, so and for the second order group, it can be overlapped with the one which we have described for first order. Okay, so you need to read the details lah in the paper, 2001 paper. Okay, in terms of how we can describe in terms of second order and third order group. So from this example, I just want to mention that the second order group can, of course, can overlap with the one which you have described in first order, because otherwise you can't use second order lah, kan? Because of course, for any structure you will describe it completely using first order, like the one that I've shown before. You cannot leave any atoms left behind. You need to describe all the atoms using the first order groups available. It's only that we add a higher level description in terms of second order, for example, so that we can increase or improve the information in terms of the structure of the molecule. Normally for second order, it is used to differentiate between isomers, for example. So basically that is used, but I think it's better for you if you can read the paper lah. Okay, so this is how it is being described, but it's okay if you, for example, if you just describe using first order and then you calculate the value, then it is also okay. But you can, of course, have the opportunity to further improve the value of the property by adding a higher order group. And if we have an experimental value, then we can of course clearly see the effect of adding second order and third order groups. But third order may not be necessary, like it depends on the complexity of our molecule. Okay, and then of course using this Murray-Rogani model and the function, then you can calculate it, and then you'll get the value, which is 528. Okay, and then here we have an experimental value given here, so you can do some trial and error. So maybe you can predict the value just based on the first order, see the value, and then see if you add a second order group, what would happen to the value. So which one should be closer to the experimental value, then you can clearly see that. Okay, and this is another example for polymer repeat unit. So for primary properties of polymer repeat unit, GC-based methods such as Van Crevelen and Murray-Rogani method adapted for polymers can be used. And for example, like this one, so we need to estimate the glass transition temperature. So basically this property is specifically for polymer. So for the polymer repeat unit given here, so this is the Van Crevelen method for glass transition temperature. So Tg is the glass transition temperature, and then this is the equation. Some detailed explanation. So Yi is the contribution. I think Ni is the number of the occurrences. Okay, and in this equation, if we change Yi with Vi, then we can calculate the molar volume. If we change it to Hi, then we can calculate the water absorbed. So Yi, Vi, and Hi are contributions which we can get it from this table. And also Mi is the molecular weight of each of the group, and Mw is the molecular weight of the whole repeat unit. Okay, so basically for these groups, we just plug in all the information into the equation, then we would obtain the answer, which is 332 Kelvin. Okay, so this is using the Van Crevelen method, and this is just to compare. So when using the MG method base model for glass transition temperature, then we will get 315. So of course we need to refer to this paper in order to clearly see the equations. Okay, so I think that is all for primary model prediction of primary properties. So maybe you can do some exercise. Okay, all right.